Hello, folks. Welcome to Rational Science, the only site on the internet that does physics. Everybody else does mathematics, irrational explanations for physical phenomena mediated by invisible, intangible entities. Okay, so what are we going to do today? Well, we're going to first move into extinction segment. Then we're going to answer a couple questions that people made since last time. And incidentally, we usually don't answer questions real time. Most of the time what we do is we take the rain check and bring it back a week later and answer the questions 1 week later. That gives us more time to analyze the question. It also does not interrupt the presentation. Anyways, then we go into our main segment, our main course for the day. And in this case, it's going to be what? The shape of the universe. We're going to find out what the shape of our universe is today. Okay, so let's move on to our extinction segment. What is that about? Well, here we say that we are the last generation of humans on Earth. Now people say, well, you have a crystal ball, Bill? Are you an astrologer, palm reader or foreseer or whatever? No, this has nothing to do with the future, really. It has to do with the past. What we do here is science, and science is about explanations, mechanisms in the case of physics, and that's what we do here. We explain mechanisms. And what we're trying to explain here is the mechanism that leads to extinction, especially to a mass extinction. And that's what that's how our species is gonna disappear, in a mass extinction. Okay, so what we do is, instead of going to the future and saying, look, what day is the last human on Earth going to die? We don't do that kind of thing. That's stuff for mathematicians, all those people, they like to do all that stuff, predictions. We don't do predictions, we do explanations. And so we have to go to the past. And some people might say, well, hold it, the extinction of man hasn't happened. What are you going to explain? And so this is what we have to understand, the context. The context is as follows. We go to the past and we figure out how animals in the past died, disappeared. Okay? And we look at the mechanism. What made them disappear? Why did they become extinct? And we extrapolate that to the human race. And if we cannot, with all our technology, all our foreseeing, and all our projections and seeing ahead and being able to react on time, if we, with all the intelligence that we have, cannot avoid the same mechanism that made the animals in the past disappear, made them become extinct, then not only do we confirm that that is what killed those animals, but it shows what we're going to die of as well, if we cannot avoid whatever hit them, whatever struck them, okay? And so how did the animals in the past die? And that's the first question we need to answer. And here you have the official versions out there from the establishment, paleontologists, and you have for different eras, for Cambrian, Ordovician, Silurian, Devonian, etc., right? And what do you find? Well, you find almost always the same mechanism. Volcanism, anoxia, changes in sea level, global cooling, CO2 depletion, climate change, methane plumes, and the famous and most popular ET impact, an asteroid. There, they fixed the problem, asteroid, right? And a lot of these have to do with what we talk about in the news today, global warming, that kind of thing. And so people get enthused because of that. It's more a political issue than a scientific issue. Okay? And of course, the main one here is the extraterrestrial impact. That's what these people essentially propose. And whenever they don't have a solution to the problem, they say, oh, it was volcanism, if it was way back when, and nobody was looking, or it was an extraterrestrial impact. And so since volcanism is probably not, no volcano is going to kill all of humanity, And we don't expect a hit from extraterrestrial meteorite or bolide or asteroid or whatever. Then we say, oh, we'll live forever, right? Because none of them will kill us, right? Well, that's only if that's true. And here, let me summarize what these people are proposing. Here it is, essentially ET impact, climate change, volcanism, greenhouse effect, ocean acidification, degradation, some people propose, and la, 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 la. There are much more. None of these can explain the only thing an extinction theory has to explain, a mass extinction theory has to explain, and that is selectivity. How does Mother Nature choose one's order, bunch of species out there, and leave all the others alive? And that applies to both animals and plants. Okay, so that's the only issue that they cannot explain, selectivity. Now, and anyone who cannot explain selectivity does not have a theory of extinction. And we haven't had a theory of extinction in the last 200 years since Georges Cuvier invented paleontology, or the French, his co-religion, his friends out there. They all invented this discipline, and nobody can explain 200 years how animals disappeared. 200 years, over 200. That was in the late 18th century. Okay, so what do we propose? How do species disappear, both plants and animals? Well, we're not going to do with plants today because that's a lengthy one and has to do with background extinction. We're not going to do background, we're just going to do mass extinction. And here you have the picture that explains it all, okay? And what you have here is that when the plants disappear, the animals that fed upon them, the animals that depended on them, disappear as well. And so just to look at a couple there, you had the seed ferns, especially in the Permian and Triassic, right? Glossopterids and what was it? I can't remember the name of the other one in Triassic. But this is when the seed ferns disappeared, and we don't have seed ferns today. We have different types of ferns today. When they disappeared, these animals disappeared. Okay. What happened in the Jurassic and Cretaceous? Well, what happened there was the conifers. This was the age of conifers, the gymnosperm. And when they disappeared, types that were around when those animals were around, when those animals couldn't find anything to eat, that's when they disappeared as well. And you can predict that whenever the angiosperms disappear, we disappear. Okay? And that's about to happen. Why? Because, again, you know, the issue is not an asteroid hitting the Earth. It's not disease, climate change. None of that has anything to do with extinction. Now, what we propose here is that there are economic collapses. And yes, all animals have economics. Economics is the management of resources. And the resource that all animals manage is food. When food disappears, the animal disappears. That's how simple it is. It's guaranteed. And when food disappears for humans will disappear. And so that takes us to the point where people say, well, why will food disappear? Okay? And that's the next step, okay? But here, let's still give you an example here, okay? And here you can see that when the conifers were essentially muscled aside by the angiosperms, that's when the dinosaurs disappeared, you know, the Cretaceous, okay, at the end of the Cretaceous. And you can see how little by little the angiosperms, not so little because it was millions of years, but you can see how the angiosperms, the number of species, were covering the land. They were multiplying in number of species and obviously as well in extent of how many of them there were. And so the dinosaurs were multiplying, but they were finding fewer and fewer food sources. You know, what was disappearing is their islands, their forests, their jungles. That's what was disappearing. So their islands kept getting smaller and smaller and smaller, and they were multiplying. They were getting more numerous, and at some point there was a critical point, and they disappeared. Okay, so that's what we propose here, that all mass extinctions have to do with economic collapses. Okay, and our economic collapse is about to happen very soon. Soon meaning, this century for sure. And if we have world wars like nuclear wars, that's just going to accelerate the process. But even the nuclear wars are an issue of economics. It's the fighting for resources. Okay, it's the struggle for resources. Okay, so the other day I presented this fellow. His name is John Calhoun. He ran his mouse experiment. First his rat experiment, then his mice experiment. And he did that from 1947 all the way to 1973. So he had many years doing these experiments, these observations. He was a psychologist, a behavioral psychologist, so he was interested in what the effects of density, right, would have on the mind, on the on the behavior of animals, especially these animals which reproduce quite swiftly. So he wanted to see if the colony expands, how does that affect the minds of the future generations? And you have to remember, he started out with 4 pairs of mice, 4 couples. Each mouse chose its mate, and they started building nests. And that was great. It was that was Adam and Eve, more or less. They were in paradise. But as time went by, even though the food sources and water was given to all the animals at all times, they had unlimited food supply. They didn't have to go out and get it. They could just get it from the mechanisms that John Calhoun created for them. And so, they were able to live in paradise, then began to multiply. And a few months later, what you have is 2,000 mice, 2,200, I think it was, or thereabouts. And then the colony began to decline. The population began to decline, and towards the end, they ended up in extinction, or in, I think he stopped the experiment a little short of extinction, but they were on their way to extinction. But more importantly, he found out that towards the end, the mice became homosexual, asexual, and autistic, which pretty much resembles our society today. So we're in that last stretch as well. That's what the world we have that we live in today. Okay, so this is the chart. You can see it here. You can see how the mice multiplied, and then reached around 2,000 mice, some thereabouts, and then they started dropping until they ended up with extinction. Okay, so that's the curve that Calhoun made, and he wrote a couple papers on that. Okay, so one fellow says the following, because he watched a video by Ed Dutton, the Jolly Heretic, and says, I believe Mr. Dutton's criticism stems from the multiple scenarios or universes from Calhoun's experiments. The beautiful ones, those that towards the end were autistic, homosexual, etc., right? Did emerge in one such universe, but it did not occur in every colony. I don't think it harms your extinction assumption, since you only offer a possible explanation in your current predicament, and Mr. Calhoun did show that, at least in mice, such an explanation is possible and understandable. Well, the issue is that I brought against Dutton is that Dutton said there are contrary results from other experiments. I didn't see that. Calhoun never had other, contrary results, and I haven't seen any other experiments that reproduce Calhoun's experiments. If you know of one, I'd love someone to send it to me. I'm willing to change my mind, but I haven't seen it. I've looked for someone running the same experiments no one has. So I guess everybody just accepted what Calhoun did and left it at that. And here you have, this is Calhoun's paper on rats, which he wrote in 1962, right? And he essentially describes what happened. So it happened to the rats as well as with the mice. He says, many female rats were unable to carry the pregnancy to full term or survive delivery of their litters, right? An even greater number, after successful giving birth, fell short in their maternal functions. They would wean their children, their offspring, early, and other mice would kill them, other rats would kill them. This is the rat would kill them, and it's like the female didn't care. She no longer wanted to have relations with the males. So they had all kinds of problems of that nature. That's what affected their psyche, their minds, right? And so there was full disruption, as he says there, right? And that's what happened to the rats. The mice, he wrote about that a few years later, and here's the mice one, okay, the mouse experiment. To day 600, the social breakdown continued and population declined towards extinction, okay? So, and you can read about his experiment, but essentially, he called them the beautiful ones, the ones that just ate, drank, slept, groomed themselves, all solitary pursuits, individualism, sleek, healthy coats, and an absence of scars characterized these evils. Okay? And he says, breeding never resumed. Behavior patterns were permanently changed. Okay? So, yeah, the issue is that I think if we ran the experiment again, we would get the same results. That density has to affect their mind. They had all these encounters with many mice, and I guess that somehow affected the way of thinking. And again, these are mammals, right? And are we any different? And they ran other types of with experiments with humans, and they said, well, we're different. Well, we're not. And it's not a question of populating the earth. I want to make sure that people understand it. Mother Nature's running the experiment with us. We're the guinea pigs here, right? But it's not in the same way that Calhoun did it in this sense. It's not that like we're in a little pen, corralled in there, and that we're all, elbow to elbow. That's not the issue. The issue is with humans is that we move from the country to the cities, and that's when we stop having babies. We can't have children in the cities. Cities are no place for children. In the country, our great-grandmothers, they had 10 children, 15 children, no problem. Half of them died, no problem either. As long as someone survived and carry out the dynasty, no problem. But that's not the case in the cities. In the cities, you cannot have children. And people think that it's a question of people being poor, people being rich. No, in the 19th century, it was the rich people who had children. So it's people have all those facts wrong. The people who had children in the past were the rich people. And today, nobody, the rich or the poor, have children, except in the country. So in the country, you'll find poor people, in a lot of countries, and they have 10, maybe 7 children. I don't think anybody has 10 or 15 anymore, but they probably have 7 children. But once those children move into the cities, I don't care if they're ignorant or intelligent, I don't care if they're rich or poor, they will not have children. Okay? So we stop having children when we come to the cities. That's where the density issue occurs. Okay? And we're also getting the homosexuality and autism that we see in Calhoun's experiments. Okay? So what's the trend with humans? Okay, how do we look as far as population is concerned? Well, here it is. I showed this the other day, the world population growth, the pink graph there. It's going up still, but it's going up at a slower rate. It's asymptotic growth, and you can see why. The green line tells us the growth rate. The growth rate is falling, okay? And as it falls, right, the total population curve becomes asymptotic. And by the mid-century, there's been a prediction, again, from the UN demographic group saying that, we're going to reach zero population growth, otherwise known as ZPG. And then I guess there's only 3 possibilities. We either continue upwards, we continue downwards to extinction, or we go more or less, up and down, at the same population, more or less. So which trend are humans going to follow? Our species going to follow? But we're going to go into extinction if nothing else happens. But something else will happen, and that will be the collapse of our economy, because we don't die in a background extinction, which is if the trend goes downwards, right? No, we die sooner than that, and maybe fortunately. We die in a mass extinction. That's going to be a food extinction, okay? Okay, so here's the trend since 1963. You can see the growth rate has been falling steadily. And at some point this century, somewhere, They say 2050, maybe earlier, maybe later, we're going to reach ZPG, okay, zero population growth. Okay, so just keep that in mind, what's up and coming. What's happening to our population also is that our population pyramid is overturning. Okay, that means we have more and more older people and fewer reproductive people. Okay, people who can reproduce, and those are the young ones. They're coming to the cities, and of course they have no interest, many of them, in having children. Others have no economics to have children, and so yeah, all those factors contribute to the population inversion, the pyramid inversion. Okay. And so one fellow says there are different findings as to whether population growth will slow down or even stop at home. And he goes in there and shows different bits of information he found on the internet of different calculations of when we're going to peak out, when we're going to reach our maximum extent. And there are different calculations, but you have to remember all these are calculations based on mathematics alone. There's very little consideration in general for what's actually happening qualitatively. In other words, the fact that people are moving from the country to the cities, and when they move to the cities, they don't have children. You know, they just look at numbers and they say, well, if the trend has been this fast so far, then by such and such day we're projecting to have so much people. And they put some qualitative factors in there to get a better idea, but again, you cannot predict that. No mathematician can tell us what people are going to do. And people are going to react based on their economic environment. If they don't have a job, they're not going to have kids. And if they can't pay the mortgage, they're not going to have kids. And there are so many other things that we have to look at before we can calculate anything. So calculations, I think, are all irrelevant, all of them. We have to look at this qualitatively and say, look, people are moving from the country to the cities. In the countries, they had lots of kids. In the cities, they will not. And they won't have kids, and that means that our population decline will probably be faster than what we think, especially if you throw in there the fact that, you know, the population is getting older because we are producing fewer young children. And so the population pyramid is overturning. There's no place for the new generations to go to work. They're going to have fewer children. The culture is also changing. There's no more of this culture of having children anymore. You know, that's dying. So all this contributes to the population inversion. And obviously there's this final, icing on the cake, which is the mechanism of our economic system. And here it is. This is another factor you got to consider, which is, I showed this also the other day, this is density-dependent birth rates. The more dense, the fewer children that animal has, that species has. And we're at the top of the list. We're subject to density-dependent birth rates, and so are all those other mammals there. Okay, so it's not only us; it's all the mammalian world. Okay, terrestrial animals, right? And what happens? The more density you have, the fewer children you have. And that's more or less what happened to Calhoun's mice as well. Okay. And here you have another factor that we throw in there just to make things a lot worse, okay? And that's that we have no genetic diversity anymore. We are all clones of each other from a genetic point of view. You take any person on Earth, I don't care if he's in China, in Africa, South America, you compare them and you'll find that there's relatively little genetic diversity across the planet. And they compared it against chimps, troop of chimps, maybe 100 to 200 chimps in Africa, and they found out that the chimps, the small group, maybe, again, anywhere between 100 to 200 chimps, they took samples there, and the genetic diversity of the chimps were greater than the entire human race of 8 billion people. So that's an eye-opener. They don't know why, and yes, we do know why. In science, they don't know why in genetics, but in science we do know. And what we found in science is that, genetic diversity for a species can only decrease over the hundreds and thousands of years. We've been inbreeding for maybe 200, 300,000 years since the origin of our species. We haven't had any influx of new genetics into our pool. We haven't slept with monkeys or or cows or fruit flies. So yeah, we've been inbreeding, and inbreeding only leads to loss of genetic diversity. If you add to that, population bottlenecks and founders effects, well, then you get the big picture. Yeah, we do have mutations every day, right? Everybody, our population in general. But then you have these big, population bottlenecks where lots of people get wiped out, and that streamlined our genetics and our genetic pool. And today we're all clones of each other, essentially. Okay? We're all equal. Whoever you marry out there is your brother or your sister from a genetic point of view. Okay, and here's our proposal. We're saying, why does humanity disappear? Do they disappear because of genetic diversity? No genetic diversity. Does it disappear because our population pyramid overturns? No, these are signs that take us to the real issue. And the real issue is here. It's the economic modes through the ages. And that is for 200, 300,000 years, we were hunter-gatherers. For maybe 10, 15,000 years, we were farmers, agriculturalists. Then maybe 200, 300 years, we became manufacturers. We got into industry, the Industrial Revolution, right? And that's when we started industry. And from there, we moved to what we have today, which are services. And maybe in the last 10, 15 years, we went into a special type of services, which are internet services. So it's no longer this labor-intensive service like, barbering or landscaping or anything like that. It's now internet. It's, there's no hands-on. So we had this trend over thousands of years, and now we're at the end of the line. Why? Because, right now we have fewer and fewer jobs, real jobs. All we're doing is services, and services is another word for unemployment. Anyone doing services is unemployed, okay, because you're not producing anything. Someone sings and you send them some money. And so what did we get? The song went away, carried by the wind. The money is just an abstraction that we give value to because we decide to accept it because we can do something with it. And when you stop to think of it, all we're doing is exchanging all these services for food. We'll work for food, that's what it is. And the way we look at this really to see if there's any real growth is we put ourselves up there in the sky with God, devil, or Mother Nature, whoever you believe in. We look at the earth from up there. We have this bird's eye view and say, what is real? And what is real are the houses, the streets, the cars, the bridges, the farmlands, whatever grows into farms. All this is real. What's unreal is services. Services doesn't exist. Services is a contract, maybe insurance. What is insurance? It's a promise. Well, we can't see the promises from up there. So the issue is, you can see growth only when you see manufacturing or agriculture. And that's now become a small percentage of every country's economy and becoming lesser and lesser every day. What's growing is services. And services, again, is another word for unemployment. Okay, so we go to the definition of a mass extinction. What is a mass extinction? You see it there at the bottom. Mass extinction, the disappearance of an entire food chain. One food chain disappears, the other one continues. Okay, why? Because they're not eating the same stuff that the other species are eating. Okay, so the dinosaurs were eating conifers primarily because they grew with the conifers. They grew with the gymnosperms. Okay, and here we were, the mammals, and we didn't care about conifers. We don't eat conifers. What were we eating? Well, we were eating angiosperms. And so as the angiosperms were expanding, we expanded with them, and angiosperms were taking over the land. The islands of the dinosaurs declined as they were becoming more numerous, and at some point there was a critical point where their population began to drop. Okay, and they ended up in extinction. Why? Because at some point they ran out of food. That's what happened. And meanwhile, we continued growing with the angiosperms, and we were in a different food chain. And the same thing happened when the Permian synapsids died, and the same thing with the archosaurs in the Triassic and so on on the line. You know, the archosaurs disappeared when the dicroidiums disappeared, which was a seed fern also. And the Permian synapsids, they died disappeared, right? When Losopterids died or disappeared. And so we can map the disappearance of plants and the disappearance of animals that depended on those plants. Very straightforward. So now you know. That's what we propose in this channel, and we're saying that we're due for extinction very soon. Why? Because as you can see the trend in that graph, the modes of production, the years that we ended up in a given mode of production become smaller and smaller and smaller, almost exponentially. You know, we're 200, 300,000 years as hunter-gatherers. You know, it took us a long time to develop, finally agriculture. We spent only 10, 15, maybe 20,000 years at most in agriculture, which I doubt, probably more likely 10,000, it's just the what came after the Paleolithic, And then you have like 300 years of manufacturing, and that started in the Industrial Revolution, give or take, say even the 16th century if you want, and onwards. And today we're in the service mode. We don't do manufacturing, we don't do agriculture because those have become ultra efficient. And what we do now is just, fool around with the computers. Okay? And so, yeah, that's the proposal here in this channel. We're about to become extinct very soon. And if we go into wars, that's just going to accelerate the process. That's all I can tell you. Okay, so let's move on. We're going to do now a couple of questions that people asked since the last time, primarily on the issue of the rope model, which is what we propose here. Here we have one fellow, and he says the following. He says, fact, phenomenons that have physical presence or have had physical presence, also known real historical facts. Example, Napoleon is forced to retreat in Russia. No, that is not a fact, okay? I'm sorry to tell you, to slap you into so that you awake. No, that's not a fact, okay? Napoleon, that's a belief. We believe it, see? And you say, well, no, but Napoleon did go to to Russia, and he fought at Borodino and all these other wars that he had. No. As far as I know, Napoleon never existed. He was never around. The only reason we know this, or we accept it, we believe it, is because we read it in a book a professor taught us in high school, and we simply believe it, okay? Can you prove that Napoleon went to Waterloo, or that he even existed? Imagine you have an Oriental guy, and he learns, I don't know, Japanese or Korean history, and he comes to the West, and you say, let me tell you something about Napoleon. Napoleon was a great general, and he fought over here, and he fought over there. And the other guy will say, well, who's Napoleon? He said, well, Napoleon, I mean, he's in our history. He's one of our forefathers, our great white fathers. And the guy said, well, I don't know if he existed or not. And he said, well, what do you mean, you ignorant fool? Sure, he existed. And in the same way, you can say, here's this great warrior in Korea or China or wherever. He says his name was Konichiwa. And who's Konichiwa? Yeah, he's a great general samurai who fought great wars, and so I don't know who he is. I don't know if he existed. See, we can only accept that by reading the book and saying, well, okay, this was passed from father to son to grandson, and we accept it, we believe it. But we cannot prove to someone, if an ET comes from another planet, we cannot prove to him that Napoleon existed, and let alone that he went to fight battles at Waterloo or wherever. Okay, so the issue is, no, it's not a fact. The only one who knows facts is Mother Nature, or God, or the devil, whoever you believe in. It doesn't matter. Father Universe keeps track of that. He's got a file cabinet, and he knows exactly what happened. But we humans have no access to that file cabinet. That's the problem. So we can only believe, we can only accept, but we cannot say it's a fact. It's a fact to you. It's not a fact to the other guy, to your neighbor. Is the existence of God a fact? Well, this guy says yes, and the other guy says no. Those are opinions. Okay, and again, here all we can say is that, yeah, we more or less think that Napoleon was there, Washington was there, Julius Caesar, Alexander the Great. We think all these people were there at a point in time because that's been passed on from generation to generation. But we cannot prove it in the sense that we cannot bring Napoleon and put him here and say, look, here's Napoleon. See, he was real. So we have no way. It's not a fact. It's just something that we accept as a fact. Humans can only accept and make assumptions and beliefs, which is different than mechanisms. Those are facts. You know, those are what comes out of the screen or out of an event. That's real. That's a fact. What we interpret as observers, as audience, that's not a fact. That's our belief. One guy interpreted one thing, another person interpreted another thing. But what came out of the incident, what came out of the screen, if someone's giving a presentation or whatever, that's a fact. That's objective. Okay? But what we interpret is subjective. And so, you know, that's why I like to put the universal movie, which is our tool, a very important tool to decide, you know, what is and what ain't. Okay, and then you have all the ones in the yellow up there. They belong in a single frame. Those are static concepts. An object, distance, location, existence, all those are static concepts. We require no motion to conceptualize any of those concepts. On the other hand, the ones on the bottom, these are just examples, by the way, they require at least 2 frames or more. Okay, and you need motion. And so the difference between the top and the bottom is the top ones are static, the bottom ones are dynamic. What do we mean by the top one, the static ones? It means that every atom in the universe is in a single frame. Okay, so in one frame we should see every atom in the universe. If we had God's eyes or the devil's eyes, right? We would be able to see every atom in the universe. And then we move to the other frame and every atom in the universe moved from one place to another. And that's the immediate next frame in the universal movie. There's no intermediate frame. Okay, so all we have for any assumption, for any theory on which that's based on that assumption, is that every atom in the universe only has location, and that we call existence. Okay, so you know, we can't go to the past to find how the atoms were thousands of years ago or even hundreds of years ago, let alone, you know, even yesterday. We have no way of knowing what happened yesterday exactly. All we can do is make assumptions about what happened. Okay? And based on that, you make your theory, right? Okay, and then another fellow says the following, or asks this question. He says, the transmission of state through the torsion of the ropes is longitudinal in my view. Longitudinal means no sideways motion. The poking is made by pushing and pulling each side of the connected atoms. Well, I don't know what he's talking about. Again, I talked about this the other day, but it's different than what you have with air. Air is, you have compression or rarefaction of the atom molecules, really. And they go back and forth. The reason we have that back and forth motion hitting the inside of our ear. That's why we can hear. We have back and forth motion. That's not the case with a rope. The rope throws in situ, and what's traveling, quotations on that, what's propagating is really nothing. It's an optical illusion. What you have is just the thumps, the torsion, the twist at the surface of the atom. Okay, so that's different than saying that something is traveling. So no, it's not longitudinal motion. Torsion is a 3D wave, you could call it, you know, quotations on that as well. It's not a wave. What you have is simply a thump at the edge of the atom. Okay, and there you see the atoms doing their quantum jump back and forth. Okay, and it's not the little bead that goes back and forth like Bohr thought, Niels Bohr. Okay, no, it's not the electron's not a bead. The electron is a membrane that encapsulates the atom. And when you look at, you know, like Schrodinger's equation, what it does, it identifies a location on that membrane, on that surface of the electron shell. And they confuse that for a particle. And so they always thought that the electron is a little particle when it's really a location on the surface of the atom. And so that's why they could not figure out, Niels Bohr couldn't figure out, why that went back and forth, and at different planes, why it can be found within a certain volume. And there you have it. It's the atom that's just pumping back and forth. The electron shell is going back and forth at great speeds, and by doing so, it torques the rope. And torquing the rope sends signals in both directions, diametrical directions. See, the longitudinal wave only goes in one direction. It goes back and forth, but it's always moving in one direction. The sound comes to my ears. It doesn't go, from my ear outwards. That's my point, okay? And so just keep that in mind. And here, let me put this other one in there. Here you can see the answer to this fellow's question. Longitudinal is one-dimensional, okay? Whereas the torsion is actually three-dimensional in that sense, right? Longitudinal is one way, whereas the rope is torsion is in diametrical directions simultaneously. And again, the sound comes in one direction. Okay, it comes from out to my ear. It doesn't go from my ear outwards. Here we're talking about something that is traveling in both directions simultaneously. So even though you have compression and rarefaction, it's not simultaneous. In other words, if it comes this way, it doesn't go that way. That's my point. Okay. The rope is not straight. The rope is taut. It's pulled tight. That's different than being straight. And again, the only thing straight is, you could say, the axis that goes right through the center of a rope. That conceptually is straight. But the rope is just pulled taut, and it's already undulated. It's an undulated entity. Okay? So it's got this DNA-like torsion configuration already built into it. Okay? And then the same fellow says it is an extraluminal velocity because little c, right, velocity of light, is not a linear velocity but an angular one. I have no idea what he's talking about. Little c is constant. Why is it constant? Because if you raise the frequency, you have to lower the wavelength and vice versa. And the only entity imaginable that can simulate that is a rope, okay, a two-strand rope. And what happens? You can see it there. It's illustrated for you. The more you torque a rope, here I can do it for you. Okay, the more you torque a rope, okay, for a given length, right? For a given length here, what you will see is that you get more links, and each link is shorter. And if you untorque it, right there, you get longer links and fewer links. And that's what it shows there at the bottom. What you see there is just an example there. You get more links if they're shorter, and longer links means that you're going to have fewer links. And again, that's C equals frequency times wavelength can only be simulated by a rope. That's why little c is always a constant, no matter what. Okay, and Einstein couldn't figure that out because he never used the rope as a model. They always used particles, discrete particles. And you can't simulate light with particles, like you can't simulate gravity with particles, as good old Newton found out. Okay, so let's get on to the main course of the day. And what is that? Well, that's the shape of the universe. What does the universe look like? What is the shape of the universe? Well, I guess a lot of it depends on if you're talking about infinity, if it's infinite, and if it's just big. Big means it has size, means you can talk about the shape of the universe. Infinity? What does an infinite table look like? Right? That's the question. And I don't think infinity has anything to do with shape. In fact, if it's infinite, whatever that means, I don't think you can have shape. Okay? So we have to separate those two. So here's the question: is the universe finite or infinite? Most people believe that the universe is infinite. Okay, but mathematical physicists, right, talk about shape of the universe and how big it is. Well, if its shape If it's got shape, it's finite. And if it's big, it's finite also. But if it's infinite, then it cannot have shape. You cannot talk about the shape of something that is infinite. In fact, it's a contradiction in terms that we will find out, because a thing, object, is that which is finite. And so you're saying it's an infinite finite. That's what you're saying when you're saying that an object is infinite. Okay. Anyways, infinite means no shape. Okay. And if the universe is finite, you must illustrate it. That's the only way. You show us what you have in your mind. Okay. So give us a picture of it. And if you do that, you got to do one more step, and that is you must identify the medium that gives shape, contrast, right, to the universe. So there you have a picture of it. If the universe is like that, that's just an example, right? What's the black stuff that gives shape to, or contrast, right, to the universe? Those are your tasks. If you can't do that, you don't have a starting point. You don't have a hypothesis, let alone a theory. Okay. Okay. So here we move on. This is how we do it in rational science. Okay. We say hypothesis. It's an assumption, the set of assumptions. And it's the objects, the definitions, and what we call the initial scene or statement of the facts. What is that? Well, you got to show us what your starting point is, where your movie starts. You got to have a first frame in the film. Okay, you can't start in the middle of the film and tell us about some theory there. No, you got to start in the beginning of the film, right? First frame, and then you're going to build your theory on that initial scene. You got to paint the picture of what we're staring at, right? We're only human. Some of us. Anyways, and then you can explain the theory, your mechanisms and causes. Again, this is for purposes of physics. And then you see the first golden principle of physics. Okay, you can't do physics without objects. If there were no objects, there would be no phenomena in the universe. There would be nothing to see, nothing happening. So you had better have objects to do physics. Okay? And the mathematicians, who call themselves mathematical physicists with quotation, they never understood that. You need objects, and they don't deal with objects. They deal with concepts. They talk about field, they talk about mass, they talk about energy. None of those are objects. None of those are things. Thing that which you can illustrate. And I challenge anyone to illustrate energy or mass or time or whatever. And that's where the problem is, the language. Okay? Okay, so in science we hypothesize, right? We have to give an assumption. We start with an assumption. And hypothesis, again, supposition, right? In science we define strategic terms. What are the strategic terms for physics? The first one is something. What is a thing? What is an object? And it's that which has shape. It's not that which we can touch. It's not that which we can see. It's not that which is made of atoms. None of that is a good definition of the word object. Object, that which has shape. Something. What is nothing? That which doesn't have shape. See how easy it was all these years? So they're antonyms. One is the opposite of the other. Shape, no shape. Simple. Very, very straightforward. Now we can use those words consistently, rationally, scientifically. Okay? And there we have it. Synonym of nothing, space, vacuum, void, emptiness, etc. Okay, so you can't make an assumption in science, in physics, right, that a thing is infinite. Why? Because it violates the definition you just gave. Something, that which has shape. So you can't say that my assumption is that this thing which has shape is infinite. No, you can't say that. if it has shape, it better be finite. It better be surrounded all around with some kind of skin. Okay? And obviously you have to identify the backdrop, what's behind it, what gives it contrast. And so there's no such thing that is infinite, right? And definitions are crucial to talk intelligently. If you don't define, we have no idea what you have going through your tiny little brain. Okay, so here we have some of the problems we started out with when we started this human thinking, human reasoning, you can say. And it started with the Greeks. They didn't do a good job at all. And they set all the mathematicians on the wrong footing. That's what happened. And here you can see it, okay? This is good old Euclid, okay? He wrote a book about 200 BC, And here it is, a figure. I'm just looking at a couple of the things that concern us right now today, right, for this lecture. So it's definition 14. A figure is that which is contained by any boundary or boundaries. Okay? So what's a boundary? Well, you look at the previous definition, number 13, it says boundary is that which is the extremity of anything. So we have a circular definition there. We say, what is a figure? Is that which is surrounded by a boundary. What's a boundary is what surrounds a figure. Great, Euclid. Great job. Okay, so Euclid did not start off on the right foot. And because of that, you know, all the mathematicians just left it at that. They never worried about definitions. And that's why we ended up with the nonsense we have today. And here we have just a criticism of that. Okay, what is a line? Well, it's contained by a boundary. And it's not what Euclid said, which is endless breadth. Okay? No, endless breadth is not a good definition for a geometric figure, because according to Euclid, it's got to be contained by boundaries. And if it's endless breadth, it's not contained by boundaries, period. So it's a contradiction there, and you have to fix that problem before you can continue. Okay? In physics, line is just an elongated triangle, rectangle. And it's not made of points like you see there. No, all figures are made of a single piece in physics. An elephant is made of a single piece. Table is made out of a single piece. Tree is made out of a single piece. So is rock. You can't say a rock is what is made of atoms. No, that's not a definition of a rock. Rock is what I point to. Okay, you point to objects in physics. You point and name, so that E.T. learns your language. You know, here, that Klingon, he visits us, and you point and say table. Now he knows what the word table refers to. That thing you pointed to. You don't say, well, it's a gazillion atoms. No, that's not a table. Because gazillion atoms is also an elephant, a tree, a rock. All of it is a gazillion atoms. But we don't care what it's made out of. That is Mariology. Mariology is religion of the philosophers. Okay? We don't use Mariology in science. In science, we have the point and name. Okay? That's how you present an object in physics. And if I point to a line, what's in front of you is a stick, a two-dimensional stick. That's what a line is, because that's objectively what's in front of us. At least two-dimensional or three-dimensional, never one-dimensional. There's no geometrical figure that is one-dimensional or zero-dimensional or four-dimensional. There's only two- and three-dimensional figures, objects, things, right? And the only ones we use in physics are the 3D ones. We don't use the 2D. Those are conceptual figures only. Okay, so line is not infinite. Okay, like Euclid said, endless breath. My breath. I'm running out of breath. Okay. Now, line cannot be infinite. Okay, that's not a figure. Okay, and it's the religion of mathematical physics who invented the infinite line. And they're not talking about line. They're not talking about figures. They're talking about numbers. They're talking about incessant growth, or incessant counting, or incessant whatever, perpetual whatever. They're talking about something else. And again, you can't unite math with physics. They're irreconcilable. Okay, and that's what geometry was. Geometry was the first attempt to unite physics with math, math with physics, and that's where we ran into trouble. You cannot do that. Okay, math is math, physics is physics. Never the twain shall meet. Okay. And so Euclid went on to the plane, and he defined it as such. He says, a line is breadthless length, and the ends of lines are points. And then he says, a surface, meaning a plane, right, is that which has length and breadth only. Okay, length and breadth, square, circle, or disc, if you prefer, or triangle. Yeah, those we understand. But he says, number 6, keep this one in mind. The edges of a surface are lines. Okay, so if a surface, meaning a plane, is lines, well, it's very simple. Okay, that means that it's got to be surrounded all around. There's no infinite plane. But that's what people repeat, today without any understanding, obviously. And so here you have the problem. Plane is a figure. Okay, no matter which plane, I don't care if it's a square, a circle, or a triangle, or whatever, it's a figure. And if it's a figure, it better be surrounded, all around by lines. That's what Euclid said. Okay, it's contained by a boundary. Okay? In physics, circles, discs, squares, triangles all have boundaries. There's no such thing as an infinite triangle, infinite square, infinite circle. No such monster. Okay, and so planes are not infinite. There's not a single plane that is infinite. But what they've done, because they're not doing physics, they're not doing the real physics, they're trying to do math, and they say, well, what if we extend the plane? Well, you can't. Because the plane, no matter how far you extend it, we better be able to see it from a bird's eye perspective to know that it's a plane. Otherwise, you have no idea what you're staring at. Okay? And again, they took away the visualization and they started doing math. That's the problem. And they introduced math where math was not needed. In other words, they confused the math with physics. Physics is physics, math is math. Keep them separate. They never should be mixed. Okay? And so it was the religion of the mathematical physicists who merged math with physics. Okay? And yeah, what they're talking about is itinerary. They're not talking about a figure. And that's where the problem is. They're talking about trajectories, motion. And so unless you put it in the right context, you will not understand what these people are doing. Okay, and same applies to solids, by the way. Here you have the infinite solid. Okay, here put a, tesseract floating around. Okay, is that infinite? Infinite cube and infinite tesseract? No. Solids, any solid is a figure. It better have, borders, surface. Okay, so it better have some end to it. Okay, it's contained by boundaries. Okay, because again, Euclid said all figures have to be contained by boundaries. That better be true, whatever boundary is, right? And physics, all of these spheres, cubes, cones, etc., have boundaries, and no solid is infinite. Okay, and again, it's the religion of math, phys, that turned all these things into infinite things because they wanted to do math. They wanted to do itineraries and not figures. That's where the problem is. Okay, so let's continue here. We have a gentleman. His name is Victor Toth. I think that's how you pronounce his name. And he's quite popular in Quora. He answers questions from a point of view of the establishment, the mathematical establishment. And he makes all these same errors. You can see it, in every one of his writings. He makes every single error known to man, known to mathematical physics. Okay, and this is where he starts. This is one point that he pulled out the other day. Imagine the Euclidean plane. It is infinite. Absolutely not. There's no plane that is infinite. Okay, but that's what he was taught, and he just repeats it. Okay, by rote. Just regurgitates it. No matter how far you go in the Euclidean plane, there's more plane beyond that point. Well, if that were the case, you would not be able to tell the difference between a rectangle, a square, a circle, a triangle, because, if it extends forever and you're in the middle of it, how do you know what plane you're talking about? In fact, you don't even know if it's a plane because you're on one side of it. You can't see on the other side because it extends forever. So you can't cross the plane to the other side. Okay, so there are many problems with their visualization. In fact, even if you're far away, right, you're this bird's eye perspective, and this plane extends forever, what is it? Even if it's, facing you, like a square would be facing you, if it's infinite, what are you staring at? Are you staring at a circle, a triangle? What are you staring at? The only way we can imagine these things is from a bird's eye perspective where you can see the whole shape all around. So there is no such thing as an infinite plane. What they're talking about is not figures anymore. Now they're talking about itineraries. You say, well, if you go, running forever until even beyond your death, right? And you find no end. Well, we'll call that infinity. That's the way they work it. So they extended artificially the triangles, the lines, the planes, etc. And that's how they get away with all that nonsense, because they're doing stuff that is unrealistic. Does it solve problems in math? We don't care. It's got nothing to do with physics or with rationality. Okay, that's the issue. They're inventing some abstractions that cannot be imagined. Infinity cannot be imagined. And there's a reason for that as well. So there again, we put the plane has to be a figure, okay? And what they're talking about is motion, okay? They're talking about something traveling or, trajectories or whatever. They're talking about dynamics. They're talking about perimeters. They're talking about, going around the circle, not about the circle, okay? They're talking about, going around the circumference or whatever. Okay, so what does Mr. Toth continues? He says, supposedly that the universe is spatially infinite. We don't know for sure. I like that. But the mathematical model that best fits the data has zero spatial curvature, which implies that it's basically a three-dimensional Euclidean space. Well, there we have a three-dimensional Euclidean space known as a cube, right? And so what Toth is suggesting is that he's got this, an infinite one, and the infinite cube, he only sees the one end of it, I guess. We don't know what's on the other end because he says it's infinite, right? So the question is, can we have an infinite cube? And if you do have one, does it make any sense? What are you staring at? What are you imagining? What are you visualizing? How can you imagine an infinite 3D whatever? What is it? It's like, imagine Atom Man inside a table, right? But he's so little, he's got all these atoms around him. Well, he can't tell he's in a table. All he knows is there's a bunch of atoms, and they extend forever as far as he's concerned. They could be infinite as far as he's concerned, incalculable ones, right? But he cannot tell us that he's in a table or inside an elephant or inside a tree. I mean, what is he inside of? And this is where the problem is. These people want to tell you the shape of something from the inside. That don't work that way, Okay, and here he gets into more trouble, this Mr. Toth here, and he says, one of the many curious properties of infinity, 2 times infinity is the exact same infinity that it was before multiplying it by 2. So, he says, if you have one apple, you multiply it times 2, you have 2 apples. We all understand that. But now he says 2 times infinity is equal to infinity. And 3 times infinity is equal to infinity. And 1,000,000 times infinity is equal to infinity. Okay, we got a problem there because he says the next step, he says, though we can do mathematical operations involving infinity, infinity itself is not a number. Right, because infinity just means to count perpetually. That's what it means, okay? Number is the verb to count. That's what number means, okay? And the word number is a verb. It's not a noun. And so infinity is simply to count perpetually. That's what infinity is. So you can't say, I'm going to multiply that times 2. You're going to count perpetually times 2, eternity times 3. Is that the way it works in math? No. And the question is, if it's not a number, why do the mathematicians introduce it into math? I mean, if you have an apple, if infinity is a thing like an apple or a stick or whatever, you can say, okay, 2 times sticks, I get 2 sticks. 3 times apples, I get 3 apples. But 3 times infinity, if it's an object, you would have 3 infinities. But infinity is not an object. You can't use the word infinity like that. So what is infinity? Well, again, it means to count perpetually, and it makes no sense to say that you're going to multiply 2 times counting perpetually. Okay, that's where the problem is. These people never defined infinity, and therefore they get tangled in their own language. This is the problem. This is where it all bombs out, all the mathematical nonsense, such as, black holes, which the singularity is alleged to be, an infinite point. And, on the other end, because mathematics goes, our universe, according to mathematics, goes from infinitesimal to infinity. It starts out as singularity. We don't know how that singularity came in there. Maybe God put it there. Who knows, And then it goes to, infinity. So we have from infinitesimal to infinity. That's their. But they never define these terms. But they want to use them. That's the problem. See, so they say, oh, we're at infinity. We can do operations with infinity, like divide by infinity, multiply times infinity, all that stuff. But it's not a number. So what are you putting? An elephant in there, saying 2 times, you're dividing by elephant, or multiplying times rock? Is that what you're doing? Obviously you can't do that. And so the word infinity, it doesn't belong in math, okay? Because what they're saying is counting incessantly. Okay, count all you want, until you die. So this is the problem. They don't have language. They don't have the proper language to communicate their ideas. Okay, so here he continues, says, if I were to take this thing all the way to the extreme in the past, what actually happened in the very early universe when stuff was very, very dense, nobody knows. Yeah, we do know, but mathematicians don't know. We can only go back so far using the science that we have. In other words, what he's saying is you take it the motion picture to the past. In other words, you rewind the videotape, and all the galaxies, all the stars, everything comes together. And at some point in the past, they even crunch together and no longer are galaxies or stars or anything. They become atoms. And before that, you have energy, I guess, this undefined word, mass, right? And you get all the way to singularity, which is what? A point where, infinitesimal point that we don't know what happens there because what? The laws of physics break down. That's how they explain it. Whatever that means, laws of physics break down. Yeah, it's simply a way of avoiding the question. The question is very simple. How did God create, objects from nothing? And here we have it. Okay, you're in the Universal movie, so there you see it. There was nothing, and in the immediate next frame, there's no other frame in between those two, right? Between frame 1 and 2, the immediate next frame you have something. And all of this individual has to do is tell us how God, or with God or without God, we don't care how he does it, how that 0D, nothing suddenly popped into and have shape and be something. Okay, so we went from nothing, which is that which has no shape, to something which is that which has shape. And there's no time in between, okay, because that's the immediate next frame. So the question is, how do you do that? What's the mechanism? With or without God? You want to put God in there? Do it, no problem. I want to see the mechanism. How did God do that? Okay, your God or whatever. And yeah, they cannot explain that. Okay, so that's the problem. Okay, and then he continues here. Finally, he says, well, it is true that the simplest cosmological model, spatially flat, homogeneous, isotropic universe with trivial topology, whatever that means, right, implies an infinite universe, and this model fits the data reasonably well. It does not mean that we know that the universe is infinite. Our expectation is that the universe behaves rationally even beyond the boundaries of the observable region. So yes, in that case, it is not unreasonable to expect that we live in a spatially infinite universe. No, impossible, because what you have to do is define your terms, and you don't have to go out there with a telescope or anything to figure out whether a universe is finite or infinite. It's very simple. This is really baby stuff, and these people haven't gone through kindergarten. So here it is, okay? I'll answer him. Says, concept, a word that invokes and embodies two objects, or two words treated as objects, okay? Universe is a concept, not a physical thing. You can't talk about the universe because the universe is not a noun. The universe is a concept, and concepts are not nouns for the purposes of physics. What does universe mean? It means space and matter. That's what it is. When we use the word universe, we're talking about space and matter. Concepts have no size or extension, and concepts are neither infinite nor finite. Okay? So, yeah, we cannot have concepts with size. Okay? Love does not have size. Intelligence doesn't have extension. Love is not infinite. That's okay in poetry, but not in physics. Okay? We're talking about physics here. What is space? Space is that which doesn't have shape. Okay? An object is that which has shape. Space is that which doesn't. And space is a concept, means nothing, literally. Space is also not a thing, so therefore space can be neither infinite nor finite, and matter includes all the atoms in the universe, plus what they call energy, which are the ropes. So it's made out of the same thing, as we'll find out, the thread. And so matter involves all atoms and the ropes that interconnect them. Therefore, the amount of matter in the universe is finite. There's only so much thread in the universe, okay, that constructs all the atoms and the interconnecting ropes. Okay, so that's the argument here. Okay, but here let's continue. Let's find out where all this leads. And here you have all these people from the establishment, famous people who make a lot of money, celebrities of so-called physics, mathematical physics actually. Lots of people, tons of people follow these things every week, every day, and they think they're getting their science shot for the week, then you aren't. They say, oh, I learned a lot, and they haven't learned squat. And so here you have them. They talk about the observable universe, the true shape of the universe, the scale of the universe, and above all, the fact that they're talking about the size or shape of the universe. The space, really, that's what they're referring to, right? And here you have another set. Okay, all these people talk about whether it's flat, it's curved, whatever. All these videos are out there, and they get thousands and even millions of hits. And what are these people learning? I mean, can anyone tell us what the shape of the universe is? Or even before that, if it's big or if it's infinite? Because big is not infinite, okay? Infinite is a little different than big. And again, you can't have an infinite universe first, because universe is not a physical object. They talk about infinite space. Space is not a physical object, it's that which has no shape. So space can neither be finite nor infinite, because it's a concept. So is universe. So you can't talk about, the infinity or the infinite universe or infinite space. These are irrational terms. Concepts are not infinite, okay? So what can we talk about? Well, we can talk about matter, if that's what we have out there, whether the matter forms some kind of pattern, some kind of shape. Okay? That we can talk about. But space and universe, they're neither big nor small, or infinite or finite. They're not objects, they're not things. And these adjectives such as infinite and finite can only be used in the context of physical objects for the purposes of physics. Okay, so here we have one fellow. He says he thinks that the universe looks like a bowl of cereal. Oh, that's great. All the galaxies and stars there in the bowl, you can eat them up any time you want. Okay, so we have these people. They come up with all these nonsense, and they get thousands of hits, right? So whoever, I guess someone out there enjoys this. I guess they're not getting any shot of science in their arm. They're just getting nonsense, entertainment. That's all they're getting. Here's another fellow, and he says, it's commonly thought that the universe is infinite. But have you ever thought about what the actual shape of an infinite universe looks like? No, it's impossible. If it's infinite, you cannot talk about the shape of something that is infinite, and that's the issue. And here he talks about having saddle shape and all these other different shapes, donut shapes and so on, and they don't have the slightest idea. And you have to remember, there you can see right in the center, you'll see the Big Bang explosion there, okay? And you can see how the universe is expanding there. And so you would think it's spherical because, there was the Big Bang right there at the center, and it's pushing all the galaxies outwards. So this is their original model, But as you will see today, we're going to change that a little bit. These people are going to change it, okay? So, but I like how this fellow ends. He says, not likely. Its true shape isn't something that we can necessarily define or grasp. Yeah, we can grasp all shapes. Believe me. Any shape that you put, on your screen, on the paper, on blackboard, we all understand it. Believe me. Yeah, shape is easy. It's kindergarten stuff. Don't tell me that you cannot comprehend shape. That, I don't know what shape it could have. Well, just put it on the board and we'll know what shape it had. What do you have in the back of your mind? Give us a proposal. What do you think it looks like? It's very simple, actually, right? Okay, so here we have another fellow. I think it's the same fellow, but he says the following. The fabric of space, according to Einstein, is a plane with gravity bending and curving that plane. But this plane of the universe isn't completely flat. It's curved ever so slightly. We don't see it with the naked eye because we're just incredibly small. Even if we were able to somehow visually see the fabric of space as a literal flat plane, we wouldn't notice the curvature because we're simply too small. Well, this is absolutely wrong, erroneous, false, okay, in this sense. We can't use that notion that he just said there, the warpage of space to explain gravity, because we can't use it here on Earth. We can't use it to explain why a spoon falls to the floor. Because in order to explain that with this mechanism that Einstein proposed and everybody else just swallowed, is that you would need to have, in that region where you see the spoon falling, you would have to have the canvas be bent locally. And Einstein doesn't propose that. Okay, general relativity is only used in the macro scenario, cosmologically. You can't use it here on Earth. You can't say, I'm going to bend space-time here in my garage or in my apartment or my living room. You can't do that. It's not a theory. It's not even a theory. It's the mathematics that Einstein put in his field equations cannot be used in a small location. Okay, so you cannot explain that with Einstein's theory. You cannot explain why the spoon falls to the floor. You can't do that. Okay, Einstein designed his theory for cosmological scenarios, the macro universe, right? Not for little things. For that, you need to use quantum. Quantum has yet to find gravity, mass, everything. They have no idea about anything of how it works. All they have is math, but descriptions. But they don't have any explanation that passes rationality. That's why they say, well, we'll never comprehend this universe. We don't speak the language of Father Universe or whatever. However, they get away from those questions. Okay, so here one fellow says Albert Einstein's theory of general relativity is which allows for the curvature of space itself presents the possibility that the universe can take one of three distinct shapes: flat, closed, or open. And there you have them. Okay, there's the flat pancake type, or you could say a sheet of paper, spherical, and the saddle shape. Okay, those are the three that these people propose. Okay, and let's see which one gets the cigar. Okay. And here you have one fellow who says, we can calculate shape. Calculate the shape of a horse. I mean, they can calculate shape. And here it is, okay? He says, thanks to advancement in our understanding of the world, we can actually calculate the shape of the universe. And he says he infers it by the amount of matter. And then he continues, it could be saddle shaped like the previous guy, right? Shape of a four-dimensional sphere. Oh, what is that? I mean, a four-dimensional sphere, what kind of shape does a four-dimensional whatever have? And then the third possibility is it's flat like a sheet of paper and infinite. Okay? So if it's a sphere, it's not infinite. It's finite, they say, because, it's got edges. But, the sheet of paper, these sheet of paper that these people have, they're infinite sheet of papers. So, they put it beyond your ability to show anything, because you can't prove infinity, with some kind of experiment. So they say, what's in infinite? And that's how they put away the question from you. They say, they don't answer the question. They say, it's infinite. And that means, I'm not going to answer your question. That's all that meant. Okay, and so here we have, let me illustrate his point here. And here we have a bunch of particles. You can think of them as stars, you can think of them as galaxies. This is the entire universe, okay? And we have so much density. Okay, so can you tell me, because of the density, right? Let's say we calculate the density exactly. Can you tell me the shape, if this has the shape of a horse or a tree or a rock? I mean, how can you calculate shape? What sense does it make to say that you're going to, by knowing the density, you're going to calculate the shape of something? I mean, these people have no clue whatsoever what shape is. Shape is what you learn in kindergarten. You point and you say horse, and everybody sees the shape of a horse. And, okay, I know what a horse is because it looks like that, what I'm staring at. That's how simple it is. But to say, let me see if I can calculate the shape of a horse through the density of all the atoms in his body. Okay, good luck, Okay, here we have the tesseract. This fellow says, when speaking of the shape of the universe, however, it's important to remember that our universe actually exists in 4 dimensions. I see. It's a 4-dimensional. Again, they put it beyond your ability to visualize it. Okay, they get rid of it. And really, they're not talking about 4 dimensions. They're talking about 4 number lines. Our universe is 4 number lined according to mathematical physics. And these number lines, they point inwards, I guess, right? Because we're locating something within space-time, right? So they're not talking about 4 dimensions. They're not talking about length, width, and height. They're really talking about 4 number lines and how they measure something and what numbers they're going to be putting in there. But they use it in physics. They bring all those concepts into physics, and they say there's this four-dimensional stuff that you can't imagine. That's our universe. Great, I can't imagine it. Yeah. And so what they do, they have these hyperspheres and tesseracts and so on. There's your flat 4D tesseract universe. So I guess that's what it looks like, okay? So he says, so any shape we talk about are lower dimensional shapes that we can understand. Yeah, nobody can understand four-dimensional shapes, and the reason we cannot understand, we don't understand shapes. We visualize them. That's why. It's not a question of understanding. Understanding, you understand certain concepts. But objects, we just stare, visualize, and say, okay, even the blind man can do it. You know, he can visualize and say, okay, I see what you're talking about. You're talking about a cube, you're talking about a ball, you're talking about, you know, a tree or whatever. That we can all visualize, okay? So when these people say they can't visualize, they can't understand, it means they have no clue. So why are these people putting stuff on the internet, you know, crowding, you know, everybody out with the nonsense that they put out there? Okay, another fellow says you can determine all this, you know, the shape of the universe with an experiment. You know, send the James Webb telescope out there and see what it can see, you know, and maybe it'll tell us what the universe looks like. Yeah, from the inside. Again, it's like Adam Man. He's inside a rock, and he's trying to figure out what the shape of the rock is on the outside. You know, you can't do that. You're Adam Man. You've got all these atoms all around you. How are you going to tell what's on the outside? Through the density? Is that the way they do it? And here it is. This fellow says, what shape is the universe? No one can be sure. Always they start there. Until we can step outside of the universe and walk around it somehow. So you got to be on the outside looking in. But he can tell you for sure that it's flat. He says, so while we all know the earth isn't flat, it looks like the universe is. So yeah, they have a flat universe. It's the Flat Universe Society, not the Flat Earth Society. Okay, we have the flat universe, and for some reason they always put that wormhole, or I guess it's the entrance. You can say it's the black hole entrance to the wormhole. What does that have to do with the universe? But see, all they want is hits, and they crowd out, you know, the science with all this nonsense. They're just providing entertainment. That's all they're doing. And people think they're getting science. They're not. They're getting a carnival, you know, clowns in a circus. That's what it is. Okay, here's another famous site on the internet and YouTube, and that's Minute Physics. And what do they say? General relativity predicts. They always predict, right? That space is not just emptiness. It's a physical dynamic thing. It's a physical thing. Space is a thing. Space can bend, it can ripple, and it can expand. Yeah, I guess that makes space a thing, right? And all you have to do is tell me what's on the outside of that space thingy to give it shape, right? All of these phenomena can be described by one idea: curvature of time. Oh my God, they're going to curve time. You know, what do? You bend the seconds, the minutes. What is it? There's only one shape space can be: a giant hyper potato. Okay, so what does this potato head say? He said, we so far have no idea why our universe has the density that it does. When it comes to the curvature of the universe, our knowledge falls flat. Okay, so I guess his potato goes back to being flat. And yeah, they they have the contradiction between the expanding universe and the fact that it's flat. You know, which is true. And the way they want you to understand it is they say, look, if the ball is very, very big and you're sitting on the edge of that ball on the surface, right, for you it's almost flat, getting flat or near flat. That's the way they say it. So that's what we're talking about when we say flat, but you're really on a ball. Well, it's one or the other. Either you're on a flat sheet of paper or you're on a ball. They can't be both ways. And they want both worlds. They say, look, since the Big Bang, we've been expanding. We have the ball scenario. But the universe is flat because it's infinite. So we have both finite and infinity in the same concept. The ball is finite, and the sheet of paper is infinite. And they want both scenarios. And they go back and forth. When you talk about the flatness, they say, well, if the surface is very big and you're very little, then it's flat for you. So that's how these people get away with all that nonsense. But I like good old Michio. And he talks about the origin of the universe. And obviously, if we have an origin of the universe that's been expanding, we're talking about the ball scenario, as you can see there on your lower left. You're talking about the balloon analogy. You're saying that the universe is like a ball, right? And so that's the shape of the universe if we follow Big Bang Theory. But what they do, they make the ball so big, and they say if you're sitting on the edge of that, then it's flat for you. But then that doesn't make the universe infinite. Only the infinite sheet of paper would make it infinite. But see, they want the best of both worlds. But he says the following, good old Michio here. He says, he's saying that the James Webb telescope now can see a little farther, and it's putting some of the theories that all these mathematicians have been living with for almost 100 years. And says that all of a sudden we realize that we may have to rewrite all the textbooks about the beginning of the universe. Why? Because right now we have, 13.8 billion years ago or something like that, close to 14 billion years ago that they say Big Bang started. But now they're finding galaxies and other stuff out there that couldn't have formed so fast. And so they may have to revise the date in which Big Bang happened, push it farther back. Okay, and that's what he's talking about. And he gives an example there saying, look, they shouldn't have existed 500 million years after the Big Bang. That's the sense he is. And so he says, we may have to revise our theory of the creation of the universe. We're possibly looking at a universe that's much older than we think it is. Okay, so for many years they've been telling us, that it's 13.8 billion years ago, and now they're going to revise it and say maybe it's twice as much as that. And, they just keep with all this nonsense. No, it's very simple. Don't tell me how old the universe is. Tell me how matter came into being from nothing. And if you cannot explain that, your Big Bang Theory is nonsense. It's poppycock. So don't try to shove it down my throat, okay? Very simple stuff. You just have to tell me how matter came into existence from nothing, with or without God. I'll even pitch God in. You need the devil and Mother Nature, Father Universe, we'll pitch them all in there. Tell me the mechanism. How does something come from nothing? That's all we need to know. And if you can't answer that question, there has been no origin to the universe. Matter has always been there because space is nothing and matter is something. One is that which has shape, the other one is that which doesn't have shape. And you cannot turn that which doesn't have shape into that which has shape from one frame of the Universal movie to another. That's how simple it is. So matter could not have had a beginning, ever. It's always been there. So what do we propose? Well, here we say we work with definitions in science so that we can understand, so we can comprehend what the person is saying. Once we define these terms, all these theories from mathematical physics die a sudden death. They have no chance whatsoever. Here it is, universe, matter and space. What is matter? Something. What is space? Nothing. Very simple. They're antonyms. Space is that which has no shape. Matter is that which has shape. We're done. That's how simple it is. Okay, so that's how we start. And now we can follow through, and what we're saying is that the so-called matter, right? Matter includes the atoms and not the energy, because there's no such thing as energy. We need objects to do physics. You can't do physics without objects. And so we say these so-called energy thingies that they had all these years, no, they're ropes that bind any two atoms. Okay, so all of it is made by a single thread. Okay, so what we do is we introduce the single thread hypothesis, the assumption. We're going to assume that this is all there is in the universe ultimately. What we have is space, which is the black stuff, giving background to the single thread, which is the bright stuff that you see there moving. Okay, and what are we saying? That this is our universe? Well, yes and no. I mean, what we're saying is if you untangle every atom in the universe and every rope that connects any two atoms, this is what you would end up with. You would end up with a single, very extremely thin thread. That's all there is out there. Okay, so space and the single thread. That's all there is. There are no particles, nothing proposed by mathematics for the last 2,500 years since the days of the Greeks. All there is a single thread in all of space. And what does a single thread do? Well, it's already done, but we say that if we untangle every atom in the universe, we end up with a single closed loop thread. And that's all there is. So if you started from one atom, any atom of your choice in the universe, and you had all the time, eternity, to walk around, you would, and nothing better to do, then you would go from one atom to the other, and you would come back to your original starting point, because it's a single closed loop thread for all matter in the universe. And there's a basic model. We're saying that the threads make up the atoms and the ropes that interconnect them. And here you see the model up close, okay? That's what it is. You see that the 2D version and the 3D version. And they're connected by a rope made of the same thread as the atoms. And so what you have is atom to rope to atom to rope to atom to rope, and all around the universe. Okay? So that's our model. This is how it's constructed. Here you can see it real quick. Okay? You have one thread goes through the center of the atom, the other one goes around, forms the encapsulating electron shell. You have all the atoms in the universe connected to it with all these ropes, and that's what it looks like more or less. The ropes, one forks around the red one and forms the electron shell. There you see it. And the other one goes through the center and forms the proton star, okay, or dandelion as we call it. Okay, so that one is the proton, and that's the electron. Okay. That's our model. That's the proposal. That's what an atom really looks like. If we had the eyes of God, we could go down there in Atom Man's world. Okay, and so with this, we can make sense. We can talk intelligently to one another. Okay? Here you have the Universal movie, and this is good old Father Universe there, God, devil, whatever you want to call him. Okay, and he exists only in one frame. Okay, Father Universe, all the atoms in the universe, they only have location. They don't know anything about motion. Motion is an observer issue. Okay, the atom is here, and tomorrow it's over there. It just changes location. And if we take a cross section of time, which is what that frame indicates, cross section of motion, you could say also, all we have is location. What is motion? Bunch of locations. Okay? And so if we look at a single frame, all you have is static concepts. All you have is location of every atom in the universe. And that is Father Universe. Father Universe only lives or exists in the present. What does that mean? It means that, he has all these atoms in the universe that comprise him, and he goes to sleep. He goes to sleep for 1 billion years, more or less like, what is it? I forget his name. Well, he goes to sleep, and he wakes up 1 trillion years later, and suddenly he finds himself, awake again. He's every atom is now in the next location. Then he goes to sleep again. So Father Universe only exists in the present mode. There is no past or present according to Father Universe. All the atoms can only occupy one location at a time. Okay? And so, Father Universe only exists in the present. It is us humans who talk about motion and about time, No such thing in Father Universe's world. In his reality, it's just location of every atom in the universe. That's all there is. And so what does that mean? If we have space and we have matter, and you could, maybe take yourself out of there and try to look at all the matter in the universe, all the atoms in the universe, right? From afar, like from a bird's eye perspective. What would you see? And so here it is, okay? This is God, and he's going to look at the universe from afar, okay? And so there you have all the atoms. Well, yeah, they would form some kind of shape, right? We don't know because we're inside that little square, you could say, or cube there, with all the galaxies, all the planets, all the stars, right? We're in there, and we cannot tell what the shape of the entire bundle of atoms forms. We could only do that if we're, there with God, seeing it from afar. But since we're not, we cannot tell even from the density of that, what the universe looks like as far as its shape. And all we can do is say, look, all the atoms, form some kind of pattern, some kind of shape, and we'll never figure out what that shape is, not from our little point of view here in the center. We can't calculate it like these people say. All we can do is speculate and say, yeah, it could be spherical, it could be irregular shape, maybe it's potato shaped like that other guy said. Yeah, all those could be true, but what it can't be is infinite. Okay, space cannot be infinite, and neither can matter be infinite. The amount of matter in the universe is fixed. Okay, and all we can do as far as the matter itself is say, look, the number of atoms in the universe has to be a certain amount, or the amount of thread that makes them up can't grow because the thread does not stretch. Okay, and so the question is, the amount of matter is fixed, and our universe, in other words, the matter in the universe forms see, if you look at it as an object, it would have some kind of form if you could be outside there looking at the whole thing from, bird's eye perspective. That's all you can say. But what the universe looks like, you can't tell. And for sure, neither space nor universe can be infinite, finite, or whatever, because they are concepts. And that's the bottom line. We'll see you next week.